Hi, if you've been wondering how you can apply the concepts that you learned in topic 2 into paper 2 questions, here's how you do it. Today I'm going to walk you through my thought process on solving paper 2 questions. I'm going to be solving a topic 2 question, but I'm just going to be walking you through how I think when I'm solving a paper 2 question so that you can apply it in other topics as well. Okay, so first things first, obviously we got to read the question, so let's go ahead and do that. An elastic climbing rope is tested by fixing one end of the rope to the top of the crane. The other end of the rope is connected to a block which is initially at position A. The block is released from rest. The mass of the rope is negligible. The unextended length of the rope is 60 meters. From position A to position B, the block falls freely. Now you might hear some people going, okay, you gotta highlight things, gotta make sure that you point out everything that's important. But realistically, in an exam session, I don't really do that. Of course, I make mental notes, but I don't really go ahead and highlight, oh, it's released from rest and something. What I do is I just move on to the next question, but I always just kind of come back to the question and look for details that I really need. So, we'll go for the first question, 1A. At position B, the rope starts to extend. Calculate the speed of the block at position B. Okay, one thing that I do for every single question that I read, right? Every single sub question that asks you to find a specific thing or do a specific thing, I make sure that I remember that and put that at the top of my head so that I don't get lost when I'm dealing with a lot of parameters and I can really focus on what I really need to do, the goal of the question. So in this case, it's to calculate speed, right? Calculate the speed of the block at position B. And we're given the situation with a lot of information. And sure, you could kind of read the question again and look through and look for the information that we need. But let's just think for a second. We're really dealing with SmoothDraw equations, right? Because in this topic, we're trying to find the velocity, the final velocity in a sense. But the reason why it's called speed is because the direction doesn't really matter. The question doesn't care if the block is going this way or this way. It's going to be falling, and we know that. So it's just talking about speed. It's not related to a direction. But the magnitude of velocity and speed is going to be the same. So we're basically given parameters to find this, right? So trying to look through the SmoothDraw equations, we're given the length of the rope, which is basically the displacement, right? And we know that from position A to position B, the block falls freely. And the fact that it says it falls freely, we know that it's in free fall. And when it's in free fall, the acceleration downwards is going to be equal to the acceleration due to gravity, which is 9.81 meters per second squared. So we know the acceleration. And we also know that the block is released from rest. So it takes a little practice, but it should come to you kind of instantly when you get used to it. When we have these parameters, we can kind of conclude that we're going to use v squared equals u squared plus 2as, this SmoothDraw equation. And when we do this, some people like to plug in numbers and then rearrange. Some people like to rearrange and then plug. I prefer rearranging everything because it's just a lot easier to see, and then plugging everything in later, just so that I don't mess up anything in the process when dealing with bigger numbers. We're asked to find the velocity, or we're asked to find the speed, so we need to find the velocity, which means we need to move everything so that on one side of the equation is just v. And in order to do that, we just square root it, right? Square root of u squared plus 2as is going to equal v. And we know that u, the initial velocity, is the block is released from rest, so we know that u is 0. And that will give us square root of 2as. And now we can plug in the values, 2 times 9.81 times the displacement, which is 60. A disclaimer, you need to know that the units really matter. Some questions will try and trick you with units, so make sure that you know that the units are in SI units, and in your final answer, make sure that you convert units into the desired unit that the question asks. So if you put this in the calculator, it should give you an answer of 34.3. Another note I want to make here is in your final answer, you need to make sure that you include the units and pay attention to the significant figures. So in the question, all the values that are given are in 3 significant figures, right? 60.0 is written in 3 significant figures. on purpose. So the question is indirectly asking you to write all your values, all your final answers in 3 significant figures. Some people will count it off, some people won't count it off, but it's just nice to know, and it's a good habit because those are some easy points if you do miss out because of that. So make sure your significant figures are correct to the values or to the number of significant figures that are given from the questions. So that's how you should write your final answer, right? You can square it, you can do whatever. That should really be up to the examiner to really find the final answer. Unless you've made it really messy, it should be fine. Okay, moving on. It says, at position C, the speed of the block reaches 0. The time taken for the block to fall between B and C is 0.759 seconds. The mass of the block is 8 kilograms. Determine the magnitude of the average resultant force acting on the block between B and C. Okay, step 1. Find what the question is asking and just remember it, right? And it's asking for the average resultant force, or more specifically, just force, right? Up until this point, when we're talking about force and we're talking about mechanics, we know that the equation that we're going to use is probably going to be F equals ma, right? Newton's second law. And from this, we can kind of write this down, or at least think of this equation, and then see if you're given the information adequate enough to find this. And okay, first of all, let's look at mass. We're given the mass value, right, of 80 kilograms. That's mass. And we want to find acceleration. We're not given the acceleration. We know that the acceleration is not going to be free fall because the rope is starting to extend, which means there's going to be some sort of tension force, and the acceleration downwards is not going to be equal to free fall. But we can find the acceleration using another Suvat equation, because we're given the speed of the block reaches 0, the final velocity, and we're given the time it takes to get to that final velocity. And so we can use the equation V equals U plus AT. Rearrange the equation so that it's isolated to only A. So it's written equal to A. A is equal to V minus U over T. And there we go. Now we have all the parameters that we need to solve for the resultant force that's acting on the block. So let's go ahead and do that. I write out everything first in terms of, variables, in terms of letters, and then I plug in as my final step. So let's plug the values in. 80 kilograms, it's in the right unit, so we'll write that as it is. Velocity, final velocity is 0, minus initial velocity. We know that at point B, we found the velocity at point B, which is 34.3 meters per second. So we can just use that value because this time the initial point is B, not A. So we know that the initial velocity is going to be the velocity at the starting point, which is B, and it's going to be 34.3 over the time it takes, which is 0.759. It's in seconds, so we don't have to do any unit conversions. Plug that into the calculator and you should get minus 3,615.28, right? That is not your final answer. Remember what the question is asking. It's asking for the average resultant force, right? We're not really dealing with directions. We haven't really used negative for going downwards and positive going upwards. That hasn't really been defined in the question. That usually means that you can kind of ignore the direction. So you can ignore this minus sign, because we'll know that the force is acting downwards because the block is going downwards. And I think that's not really asked in the question, so you can get rid of that. Another thing, significant figures, right? And, I forgot the units as well. So make sure when you're leaving the final answer, you go through it and make sure that everything is correct. So 3,620 newtons will be the adequate final answer. Some people will give you points for this, but the second one is how you should write it. Sketch on the diagram the average resultant force acting on the block between B and C. The arrow on the diagram represents the weight of the block. So we're given a free body diagram to work with here. And we know in free body diagrams, 2 things really matter: the direction of the arrow and the size or the length of the arrow. So we need to make sure that we get those 2 things correct. And that's why this question is most likely 2 marks worth, right? So first of all, the direction, that's easy. It's going to be going downwards, right? Because we're talking about the situation from B and C, and we're already given that, it's going downwards. So the force is going to be downwards. But we need to know the tension force, right? We need to know all the other forces that are acting on the block. We know that the weight is the force applied by gravity, but there's going to be another force acting on the block, and just assuming that there's no air resistance or anything, the rope is going to provide a tension force going upwards, because we know that it's being stretched, right? From this point on, it's being stretched like you're stretching an elastic band. And so it's going to apply some sort of resistance, pulling in the opposite direction of gravity. So we can draw that on the free body diagram, and we can label that as Ft, or the tension force. One thing to note is that we know that it's going downwards. We know that the block is going downwards. So we know that the net force should be going downwards. If this tension force is drawn too big, that's not going to hold true, right? So we need to make sure that the tension force is smaller than the weight. And when we draw the final resultant force arrow, right, we need to make sure that it's smaller or shorter than this initial weight arrow. So then this should be your final answer. I don't know if you really need to include this in your answer, but it might be nice to have just there. But these 2 marks are most likely given from the direction and the magnitude. So remember that when you're doing free body diagrams. Calculate the magnitude of the average force exerted by the rope on the block between B and C. Okay, so we're basically told to calculate the force exerted by the rope, which is this tension force that we talked about. We're now asked to calculate this force. So force exerted by the rope, that's what we need to find. So we know from this diagram that the vector sum of the weight and the tension force is going to equal the resultant force. And we know the resultant force because we found it here, right? So we know that the resultant force is going to equal the vector sum of the force due to gravity, and tension force, right? So from this relationship, we can kind of just derive what the tension force is going to be. So the tension force, if we move everything to the other side, is going to be the resultant force minus the force by gravity, which is also known as weight, right? You can write that as weight because it's referred to as weight here. And we can kind of think for a second. We know the resultant force already, right? 3,620, if I'm not mistaken. Yeah. And we got to find out the weight. What do we do with the weight? How do we find the weight? It's usually given by weight is equal to mg, right? The mass of the object and the acceleration by gravity. So we're given the mass of the object, which is 80 kilograms, right? So we're given 80 kilograms, and we're given the gravity, which we all know, the acceleration by gravity. If we put that in the calculator, we get 784.8. I mean, to be honest, what I should have done really is rewrite this as the resultant force minus mass times gravity, and then plug everything in here. So 362 minus 80 times 9.81. That will give you 2,835.2 as your tension force. Remember, you need to write this final answer in the right significant values and the right units. So 2,840 is going to be 3 significant figures in newtons because we're talking about force. So there you go. That's your final answer. Moving on to the last few questions. For the rope and block, describe the energy changes that take place. So this is really fully conceptual. There's no calculations here. And these are the kind of easier ones that you need to be able to answer. So we're looking at the energy changes that take place between A and B. So let's kind of look back at the diagram. We know that from A and B, it's initially at rest. So we know that there's gravitational potential energy, right? And it's going down in motion, transferring all that gravitational potential energy into kinetic energy. So we can say that from A to B, the gravitational potential energy of the block is going to the kinetic energy of the block. And this question is 1 mark worth, so that should be enough. And between B and C, we know that it's already in motion, so the entire mechanical energy at B, the gravitational potential energy. Remember, there's still gravitational potential energy at this point. It's not at the ground level. So there's going to be a gravitational potential energy. And there's also going to be kinetic energy because the block is in motion at point B. So we know that the gravitational potential energy plus the kinetic energy moves down and in turn turns into elastic potential energy in the rope, right? That's fully conceptual, right? So we can say that the gravitational potential energy plus the kinetic energy transfers to elastic potential energy. If you're writing this in your final paper, you should probably write this in words, but I'm just going to say this because it's easier to see. Finally, the last question, the length reached by the rope at C is 77.4 meters. Suggest how energy considerations should be used to determine the elastic constant of the rope. So we're given the length of the rope at C, right? And we're asked to suggest how energy considerations could be used to determine the elastic constant. So we're asked to find the elastic constant, or at least provide us method in which we can use to find the elastic constant. So we know that the elastic potential energy is equal to half times K times the change in displacement, right? So the displacement basically squared. So from this, and from what we found in the previous question, we can say the elastic potential energy is going to equal the gravitational potential energy plus the kinetic energy at point B. And since we have all the values that we need to know, we can find the gravitational potential energy, we can find the kinetic energy, and we can find, if we let's expand this here, half times kx squared is equal to mgh plus half times mass times velocity squared, right? Those are the equations for the individual energies. And you can say, you can make a statement. You don't have to find it. I don't think you can find it. Maybe you could, but it's not worth it. That's not really asking here. That's not what the question is asking. It says, suggest how you could determine the elastic constant. So you could say, rearrange to find K. Something like that. Something along those lines. Worded better and written more in a finalized way. Not so rough like this, but I don't know, maybe you'll get points from this. You could try it out, but I've never done that in my exam before, and I don't think I will. I think I'm just going to write in full sentences just to make sure. But this is the content that you need. Basically, you need to show that the elastic potential energy is equal to this, right? And we need to use what we derived from the previous question to get to find the elastic constant, which is K. So there you go. That is my thought process in how I go through to solve a paper 2 question. That was a little long, but I really had to explain how I thought. So hopefully that helped. I'll be making more paper 1, paper 2 question videos, example problems, because physics, you kind of just have to practice a lot. Yeah, there's a bit of theory that you need to understand, but it's mostly about practicing problem solving, because it's really hard. That's probably the most difficult part, applying what you learn. So I'll be coming up with more example videos. Hopefully I'll be able to help as much as I can. If you have any questions, you can always ask in the comments. I will be replying to every single one of them. So yeah, thanks for watching. I hope it helped. I'll see you in the next video.